Hello, everyone. Welcome again to your study part, where we put into place our preparation concept for physics as a subject. So we'll quick start into what we have for today. All right. So looking at what we have done so far, you discover that we've been able to touch on various subjects, various topics with regards to our physics. Talking about topics like we pick density, relative density in relation to Archimedes' principle, as well as focusing on upthrust as a force. We were able to also look at specific heat capacity at some point. We looked at capacitance and resistance in terms of it being a topic for which we are being asked in our examination. Furthermore, we looked at AC circuits, how it applies to our examination. We also studied transformers in terms of the formulas attached to it. We were able to touch light on some part of wave. If at any point you were not in class while we're doing this, you could always request for it on the platform for them to kind of upload the videos for you so you can rewatch again. And it's easy for you to ask questions bothering you as regards those topics. So without wasting our time, today we'll be looking at another interesting aspect of physics and talking about radioactivity. If I may ask, anyone in the class that has done radioactivity before now? Radioactivity. You know we have radioactivity in chemistry, but in physics we don't dwell on every part of radioactivity. There are some key parts and I would say very easy parts that you're expected to know under what? Under physics, talking about radioactivity. So how many of us have an idea of radioactivity before now? Anybody? Okay, beautiful. So make me proud in terms of our journey this day. Here is it, the focal point. What are the key things we want to look out for in terms of radioactivity? Remember, for every sequence of topics we pick, we try to look at what are the highlights of that topic that is important for us to note in terms of our JAMB journey. Here is it. The first thing is the definition. Okay, topic first. Let's have it. We said we are looking at radioactivity. Radioactivity. So, the definition. We want to be able to define radioactivity. Then, we want to be able to what? Explain the types of radiations available. Types of radiations available under radioactivity, as well as the properties of these radiations. Very important. So when we identify the properties of these radiations, then we can push forward into the decays that we usually will look at, talking about alpha and beta decays. So nuclear decays. Nuclear decays, and we lay emphasis on nuclear reactions as well. So easily I'm trying to refresh your memories as to those aspects that you have scattered along the line of your memory. Try to kind of put them into perspective. We have decays whenever we're making reference to alpha decay and beta decay. Here, whenever we're making reference to our nuclear reactions, talking about fission and what? Fusion, remember. Now, when you are done with this journey, then you can talk about this guy. Half-life. You want to work on half-life, but you must pick on the equation first before you work on half-life. Let's pick decay equation, general decay equation. So it's from the decay equation we are going to be having our half-life projecting out. So the sweet thing is, most times students will think, oh, once they get to half-life, that's the end of it all. No. We know that what? Immediately you are done with reading half-life, you have to push it a step further to note this guy, binding energy. You want to have an idea of what binding energy is, and also this guy, binding energy per nucleon. Binding energy per nucleon. So when you are able to cover all this, then you know that yes, you are good to go. How many aspects? 1, 2, 3, 4, 5, 6, 7, 8, 9. When you have these 9 aspects checked out, then it means you are good to go with respect to what? Radioactivity. Topic radioactivity is said to be what? Covered. We want to be sure that everything under this aspect, we are good to go with it. Once you can handle questions effectively without any problem, covering these 9 aspects, then you can say that what? Radioactivity is done and dusted. Remember, 47 topics which was categorized talking about your 4-in-1 textbooks, 38 talking about your JAMB subcategories. So whichever number of topics they are sharing it into, you have radioactivity as one of them. So having been able to answer questions under this, you know that one aspect is taken care of. So let's have it. Radioactivity, the definition. So what are they looking out for? We say that oh, sorry, I'm just writing. I wasn't saying anything. Okay, I was just writing. Oh, pardon me. Okay, you are used to my usual style of reading it out. Okay, we have that radioactivity is the spontaneous disintegration of a radioactive, unstable, note that word, unstable material. It is the spontaneous disintegration of a radioactive, unstable material. Another breakdown, I'll still write the same thing I've written. What is the small English for the word disintegration? We're having breakdown. Disintegration of an unstable radioactive material. With the release of energy. The spontaneous disintegration of what? Unstable radioactive materials with the release of energy. That is what radioactivity is. So energy is usually released when these unstable materials disintegrate. You can take, for example, you pick your carbon, for example. Would agree in chemistry that what? Based on the periodic table, carbon would be 612C. But an instance, this guy here now is the stable form of carbon. The moment you are producing an isotope, I'm sure you are familiar with the word isotope in chemistry. The moment you are producing an isotope, meaning a family of carbon that does not have what 12,6, that peradventure has 13,6 and is still carbon, then a problem occurs. It becomes unstable. Since this is not the natural state of it, what happens is this guy tends to what? Break down into a smaller version of itself. And in the process of doing that, energy is released. So the definition, but most often than not, we don't have them asking much about the definition of radioactivity again. You know, your UTME examination, they feel that what? That is just too cheap. Why would they pay whatever amount they are paying to register JAMB and will be giving them something as easy as this? They don't want to break that record. Before you start having students scoring 380 in JAMB, then they want to make sure that what? The whole system is very, very difficult. And yes, you can prove and defend that 380. So they still want to leave it at the scope of 360 something and maintain it like that. So they won't give you this most often. Why? It is just too cheap. Let's dive into the types of radiations that you can have under radioactivity. Types of radiation. There are three of them, which some of us are familiar with already. The first being what? Alpha particle. The second being beta particle. And the third being gamma ray. We don't call it a particle, we call it a ray. Gamma ray. So definition, we've answered that. Types of radiation, we are looking at it. So these guys form the basis of the types of radiations that can be emitted. Beta particle. Then the last guy, gamma ray. This guy form the types of radiations which we can have. Having understood that we have alpha, beta, and gamma rays, then the differences in terms of their property is what sells as far as what your UTME examination is concerned. They want to test your understanding about the various property that each of these guys have, talking about alpha radiation, beta radiation, and gamma radiation. So let's look at them. We set it in a form of table, in a tabular form. Properties. Here we go, radiations. We have alpha here. So these are the properties. Properties of radiations. Alpha, beta, then we have our gamma. So let's start. The common, frequently asked properties. The common and frequently asked properties. What are they? Number one will be in terms of the charge. They expect you to know what charge alpha particle will carry, what charge beta particle will carry, and similarly, gamma ray. What charge do they carry? We say that what alpha particle carries what? A positive charge. Alpha particles are generally what? Positive charged. Beta particles are negatively charged. Gamma, neutral. They don't have any charge. So, in terms of the charge, positive alpha, beta negative, and gamma neutral. We talk in terms of their what? In terms of their symbols. How do you represent them? Yes, aside using alpha, beta, and gamma, we say that what? Our alpha particle is represented in terms of our helium element. 4, 2, helium. This is the representation for what? Our alpha particle. What about beta particle? Our electron, 0, -1, serves as the way we will represent what? Beta particle in any given decay equation. What about gamma? No symbol. Why? It does not what? Have any element representation or particle representation for it. Then we make reference to the penetration power. Penetration power. How best do they penetrate any substance? How best do they penetrate substances? This guy, alpha particle, has the lowest penetration power. In terms of the penetration power, lowest penetration, we are talking about our alpha. Medium penetration, we are talking about our beta. And highest penetration, talking about what? Gamma. We now make reference to our number 4. Based on this what? Based on this property of penetration power, then we need to look at the stopping material. Because JAMB would ask you, stopping material. What can you use to stop alpha particle whenever it is what? Moving along a given path? Then you want to talk about what? An ordinary piece of paper can stop what? Your alpha particle. Because it has a low penetration power. Alpha particle would easily be stopped with what? A piece of paper. Beta particles, what can you use to stop them? Then you are going for what? Your aluminium foil. Your aluminium foil. That would be what? A perfect instance used to stop what? Beta particles. Your gamma particles, what can you use? Definitely not paper, definitely not aluminium foil, but your lead block. Your lead block. That will be the best material you can use to stop what? Gamma rays. You want to make use of what? Your lead block. Remember, what can work for gamma will definitely work for what? Alpha and beta. Since lead block can stop what? Gamma rays, which has the highest penetration power, it can stop your beta particle and your alpha particle. Paper can only stop alpha particle. It cannot stop what? Beta and gamma. Your aluminium foil can stop your alpha and beta particle. It does not stop gamma rays. Only your lead block can stop what? All the three, considering the fact that what? It can stop the strongest form of radiation. Pushing ahead. You talk in terms of your ionization power. Ionization power, meaning ability to react as it moves along what? Different medium. We say that what? Alpha particle has the highest ionization power. The highest goes to what? Alpha particle. Your beta takes medium. While we say that what? Gamma takes the lowest ionization. It really reacts on its way, on its path, along various substances. It really reacts whenever it's moving through various substances. We didn't say it does not react at all. We say it has the lowest level of reaction. That is why they will tell you that what? Medical students in the house, MBBS, please can you tell me what's the full meaning of ECG? Medical students in the house, biology students. Whenever they are teaching you, biology teacher is teaching you hereditary or genetics, hereditary and genetics in biology, SS3, I remember very well. They will mention that a woman should not be exposed to ECG more than 3 times in the complete 9-month trimesters that she's going to have. What is ECG? Biology students. God bless you, ma. So, that's exactly the answer. Your electrocardiogram, you should not be exposed to it more than 3 times, especially in our country, Nigeria. And you know why? So, the reason is because what? You cannot guarantee the effectiveness, the functionality of that machine you are making use of. 3 times would not be too much because our X-rays and our what? Radioactive machines, which we are meant to use medically, they are conditioned into becoming what? Mild dose. They give out mild dose of radiation. Mild dose. Meaning, thank you very much. You can mute yourself. They give out what? Mild dosage of such radiations. When it becomes excessive, then you are going to have the problem of what? Genetic mutation. Biology students, I'm sure you are familiar with that. Then albinism will take effect. A child whose mother is not an albino, whose father is not an albino, all of a sudden the parents are giving birth to a child with albinism. It's because of the genetic mutation that occurred as a result of what? Exposure to some of these what? Radiations. So, we are saying that what? It is not as if gamma ray does not ionize. It only has the lowest form of what? Ionization. Having known in terms of ionization, we have 2 more which you must know. And that's talking about the deflection. The deflection in magnetic fields. The deflection in magnetic fields. So, how do we put ourselves in place knowing about the deflection? Then we have to understand that as far as the magnetic field is concerned, there are 2 poles that you always have. The North Pole and the what? South Pole. North and South Pole. Bar magnets. The North and the South Pole. We've always attributed that what? Like poles will always what? Repel. Unlike poles attract. Anytime you place an alpha particle inside the magnetic field, it is always deflected to the South Pole. Deflected to the South Pole. When you place a beta particle inside a magnetic field, it is always deflected to the North Pole. But for this guy, gamma, no deflection. And you'll see the reason more when we are now talking about the number 7th one. Number 7 will be deflection in electric field. Deflection in electric fields. As far as electric field is concerned, we know we are talking about positive terminal and negative terminal. Positive terminal and negative terminal. Your battery, for example, positive terminal, negative terminal. Check this guy out. Alpha particle, we said what charge does it carry? It carries positive charge. Since this guy is positive, you don't have it what? Getting attracted to positive. It's not possible. So whenever you have a positive and a negative terminal, this guy will be attracted to the negative part. Similarly, beta is negatively charged. And we are having what? A positive and negative terminal. This guy will be attracted to the positive terminal. So, because unlike charges,